Well, hello my dear students, how are you all? Welcome to Deeksha Karnataka YouTube channel. I hope all of you are doing good. This is Bacha Masterstroke for Matrices. As you know, we're going to complete the entire chapter in one shot. Okay, we'll focus more on the concepts and less on the problems. I've taken I think 7 questions today as well to cover up all the concepts that we have. I want to create a bridge between your concepts and the problems. That's why I've taken those 7 questions. If you're somebody who want to learn this session, this particular chapter in more detail, okay, which is very important again because it helps you learn determinant also easily. So if you want to learn detail, what you can do is go ahead and check my session for matrices in the playlist of maths for KCET 60 to 60 series. Okay, again, if you want to solve more questions, you can solve there as well. Today I'm going to solve only 7 questions and more questions we'll solve in the live sessions. So I hope that is clear. Okay, so let's quickly start the session without wasting any time that we have. Okay, so one shot for matrices is over here. Please check. What is there, sir? First thing is, sir, about your what is a matrix, bacha? Different types of matrix. These things you should know. Please go ahead and check it out from a definition from NCERT. So usually they don't ask questions on this. That's why I'm not taking much information over here. Very simple things. So basic, you have to go through the definitions. Okay. What is it? It's a rectangular array where you store the data. It can be real, okay, it can be a complex number also, but we are dealing with real numbers over here. We can also use complex numbers. I think I've taken a question which will use complex number matrix as well. Okay, so definition is basically a rectangular array. Okay, means it will have a row like this, 1 2 3 like that so far, and also you'll have columns, and in that everyone will be having an element space where you put the elements that can be complex and real as well, okay, or can be a function as well. I can take sin x cos also, that is a function. Okay, I can take xy, that is a linear function. Okay, so it can have functions. So the elements can be, the element of a matrix can be a function, can be a real value, or can be a complex value as well. Means imaginary part can also be there in a matrix. Okay, we have to solve for that. For whatever questions are given, they can ask you to solve the questions on that. Okay, the matrix questions can be expressed in any form. Now what else? We have definitions like zero matrix, null matrix, diagonal matrix. Okay, so all of this, please go ahead and learn it, but I'm not dealing with that all of here. Whenever I get anything relevant to the question, I'll explain it to you. Otherwise, I'm asking you to please revise this basic formula from your end. If you want, I can tell you that go ahead, check the sessions in the KCET series where they have taught you the formulas, the definitions as well. Okay, so basically null matrix is matrix with no entry. Okay, basically zero matrix. Okay, we have identity matrix. Means identity matrix, this is very important. I'll tell you this part. Basically all diagonals is 1 except for our diagonal element will become 0. Okay, so diagonal element is 1, others are 0. Okay, what is this called as? This is called as 3 cross 3, or also called as square matrix. It's called as square matrix. We have two types of matrix, bacha. We have square and rectangular matrix also is there. Rectangular matrix also we have, है ना? Over here what happens is in the order number of rows, usually we write it as m, okay, will be equal to n. In this case, rectangular matrix, m will not be equal to n. What is m, sir? M represents number of rows, whereas n represents number of columns. I hope this is clear. N is the number of column and m is the number of rows. Okay, so when they're equal, we call it as square matrix. Otherwise, we call it as row matrix. Okay, so we call it as rectangular matrix. Forgive me for that. Let's quickly move on and see some operations, which is very important again. Operation on matrices. So what we can do, sir? We can do addition, subtraction, and scalar multiplication. These are very simple operations. They are very simple operations. Means when can we add, when can we subtract, when can we multiply with a scalar number? Means when I say I can take a constant 2, multiply to that. I can take constant minus root 2. That also is scalar only, right? I'm not talking about rational or irrational. Any scalar number, 2, root 2 like that, I can multiply to the matrix. How will it look like? So we'll talk about all of that. Okay, but when we come about, so these are very simple concepts. One operation is called as matrix multiplication. We have to multiply a matrix to a matrix. That will be a little challenging. Not challenging, just time taking problem will be there. We'll see that as well. Okay, so what we have, first thing, addition. So what we have to know for addition, bacha, is that order should be same. Should be same. What I mean by that, it means if I have a matrix A, let's say, with the order m cross n, then matrix B also has to have same order, bacha. It has to be having the same order. So basically, addition, subtraction, and comparison and comparison is done only when the order is same. What I mean by comparison, sir, is which is greater. I can say A is greater than matrix B. Okay. When, sir? When, bacha, we can say the matrix order is same. Okay. Basically, I can say they are equal also, right? When can we call the matrix are equal? First thing is order has to be same, and then the corresponding element also has to be same. For example, let's say I'm writing 2 cross 2 matrix. Okay. I have 4 entries over here. This is a 2 cross 2 matrix. Okay. Another matrix like this, 2 cross 2 matrix. When I can say the matrix is equal, when all the elements, corresponding elements are equal, bacha, means this equal to this part, this equal to this equal to this, and this equal to this. Means all the corresponding elements has to be equal to each other. Looks messy, I'll just erase that. Okay, so let's just take it out. So all the elements, corresponding element has to be equal, then only we can say it's a equal matrix. I hope this is clear. That is very, very simple. What else we have, sir? Scalar multiplication. What about subtraction, bacha? Again, you can just take it out. No, you know the subtraction is again a different type of addition only. How can I say that, sir? If I'm writing, let's say A plus minus B, it will become what? A minus B, no? Simple. So I can express the subtraction in terms of addition. Okay, so the condition will remain same for subtraction also. What is the condition? Order has to be same. Order has to be same. Perfect. What about, bacha, scalar multiplication? We are multiplying a scalar number. For example, let's say I have 2, 4, 1, 9 as a matrix A. Okay, as a matrix A. Now they want you to find the value of matrix 2A. What is the answer going to be? Simply multiply 2 to all the entries. So 4, we have 8, 2 and 18. That's simple. If it was, let's say, minus 2A, it will become all negative. So basically you can multiply any numbers to the matrix this way very simply. It doesn't matter what is the order. You can multiply to all the elements. Is that clear? Order will be very important in the case of addition, subtraction, and when we are dealing with matrix multiplication. Wherever you are dealing with matrix to matrix operation, no, I repeat myself. Whenever you are dealing with matrix to matrix operations, then you have to use order part. Okay. Let's look at some questions. Achha, before that, I have a very important announcement to make for to all of you. It is again for you only. Okay, so what we have done is, we have, as we promised, as your request was there, we are here with your KCET Abhyas test series. Okay, now in that, bacha, you will get 35 tests. So I'm not asking you to purchase right now, right away. First of all, this test is already live now from 7th of February. So it's already available on the platform for you to purchase, and a lot of students have already purchased it. So I'm very thankful for all of that. One more thing. So in that, bacha, what we are doing now, we have done a very unique thing. We have given you 4 free test series. Okay, for one for physics, one for chemistry, one for bio, one for maths. Okay, so what you can do is just go ahead, take the test. Again, you'll get question paper, solution also you'll get, and you'll get a video solution as well. So PDF solution is also given, and also subject wise you have video solutions also available. Okay, as you had in Success Blueprint test series. Okay, so you can go ahead, try the test. If you feel it is good, if you actually think that it's going to help you in the preparation, which I am telling you it will, you can access the entire test series right now at $14.99. When you do that, you get the Success Blueprint test series at only 1. The PU2 test series you get for only 1 rupee, which is including in this price $14.99. Okay, right now what you have to do, I'm asking you all what, go ahead, enroll, just register for free. For 0 rupees you can register and take 4 tests if you have not purchased yet. If you have purchased, then very good. Again, for all you have purchased, don't worry, bacha, you'll get all the instructions videos coming from our side, how to access test series. Okay, how to access platform. There are a lot of modifications being done to the platform to help you, get the better result, or best possible way, how to compare your scores. Everything will be there on our platform. So you'll get all the information about that on our very soon. You'll get on our, I think today only I'll get, or maybe you've got this yesterday. Okay, I think you must have got the video. One more thing I want to say. So apart from this, you have 31 paid test series. Okay, so in that you'll have 31 paid, 4 is free, as I said, 31 is paid. In that you'll have full syllabus and chapter wise test. What else? You have detailed video solutions and analysis. We have chapter wise one-shot revision videos. Okay, and chapter wise insight for last 5 years for KCET papers. Okay, so all of this will be given to you in the Abhyas guest test series. Okay, so please go ahead and enroll right now. As bacha exams keeps coming closer, demand will increase, prices might also go up. Please avail this offer launch price right now. Okay, so that is all. One more thing I want to say, for all students who don't want this, like right now, bacha, there's an offer going on right now for success blueprint test series, as PU2 boards has come closer to us. And if you are somebody who wants to, as I say, I have seen in your in the live sessions comments of, can you make it free, can you make it a little cheaper? For that, bacha, there's 20% flat discount going on right now on your PU2 success blueprint test series. Please go ahead, avail that as well. Okay, but if you want to purchase both together, you can get success blueprint test series for only ₹1. Okay, chaliye, let's move on now. I understand I have taken a lot of your time, please forgive me for that. Let's quickly get back to helping you in the one shot of your matrices. What is the first thing? Operations on matrices, addition of the matrix. What we can do over here is simply, I've already explained you all of these things, but again we can go through this quickly. Okay, what is that? When a matrix is written like this, Aij, what is A represents, bacha? The element. I represents the which row it is in. J represents which column is it in. Okay, same thing. Bij is that the second matrix. You can define the sum like this: Cij, where C is given by Aij plus Bij. Okay, those two matrices of same order are added. This is very important. Same order are added by adding their corresponding elements. You have to add the corresponding elements to get the addition done. Okay, two matrices which can be added are conformable for addition. Only this when it happens. Adding of A and B are not defined when A and B are not have same order. Same thing I have explained right in the previous slide. Chaliye, can I quickly skip this part? Please allow me. What I have, same thing bacha over here also. If you want, I can take an example. Let's say write matrix here 2 4 6 9. I have a subtraction matrix here 1 3 2 4. Subtract, sir. 2 minus 1 bacha is 1. 4 minus 3, sir, is 1. 6 minus 2, sir, 4. 9 minus 4 is 5. We could do this because the order was same. Yes, 2 cross 2 and 2 cross 2. If it was a different order, we can't subtract. Okay, order is same, means we can do the subtraction like this: 2 minus 1 for the first element, 4 minus 3 for the second element, 6 minus 2 for the third element, and 9 minus 4 for the fourth element of the resulting matrix. If this is, let's say, matrix A, this is matrix B, this is what, sir? A minus B. I know it's very simple. Okay, let's quickly move on from it. What is it? Properties of addition of matrices. What we have, so first property is matrix can be added in this way. Commutative properties, working on this, can be availed on this. What is that? A plus B and B plus A are both equal. Either you add A to B or B to A, will not change your result. Okay, A to B or B to A will be same thing. Okay, again order has to be same, of course. M into N, they've given no same order for the both the matrices. What else is there? So property number 2, also associative, sir. The property is also associative. Addition is also associative in the nature, means either you add A plus B together, then you add C to it, or you add B plus C together, then you add A to it, will have same result, no difference in the result. Okay, property number 3, what we have something called as additive in identity. Okay, means if you add something to this, will remain itself. What is that called as? Null matrix. What is it called as? Null matrix, bacha. There exists a matrix, if you add to the matrix itself, will remain unchanged or unaltered. Please check. A added with 0 remains A only, or 0 with A remains A only. Property 3 is also defined. Property 4, existence of additive inverse. Okay, so if you add A to A in A minus, okay, basically if I'm adding A to negative of A, what is that, sir? A minus A. What is that, sir? 0 matrix. Okay, you get a 0, which is a null matrix. So there will exist a there will exist a matrix which will called as additive inverse. Last one, cancellation laws hold good for addition of matrices. That is, if A, B, C, B, any three matrix, we can write here A plus B and A plus C, right? It means A and A will be cancelled. We have B equal to C. Okay, left cancellation law, for right what we have, we can cancel A and A from here. So what will we have? B equal to C. Right cancellation law. Simple things, not difficult, just had to go through this. Please remember these things. I know you already do, but just I wanted to give you everything in one place. That's why I've mentioned all of this in the slides. Properties of scalar multiplication. Okay, have a look. Scalar means taking a number. So let's say the scalar is lambda over here. Lambda be any scalar. We can do, sir, lambda times of A plus B as simply lambda A plus lambda B. So basically what is this, sir? Distributive property on the multiplication. Okay, minus lambda into A is simply what, bacha? Lambda times minus A. That also is okay. Simple, no? I can multiply anyway and put a minus sign. That also works. Okay. Property 2, what we have, let A be any matrix and lambda any mu. We have 2A over here. We can write here lambda plus mu times A as lambda A plus mu A. Again same property like this. Instead of two matrices over here, I have only one matrix and two scalars. First one we had 2 matrix, 1 scalar. Here we have 2 scalar, 1 matrix. Property will remain same. Lambda times mu times A, we can multiply first lambda mu or mu lambda anyway is okay, not a problem. Okay, chaliye. What is the question number 1? Let's solve this. Find a non-zero value of x satisfying the matrix equation. Let's do this. First we'll multiply this part, then compare over here. X into 2x, 2x square. This will become 2x, this will become 3x, x square. First matrix is done, bacha. Second matrix. Multiply 2 into 8 is 16, 10x. Over here I have 8, here I have 8x. Okay. What I have here is correct. 48, here sir 20, here sir 12x. Okay, I want to solve for x, right? Which can I compare? I think this will work. 2x plus 10x equals to 48. 2x plus 10x equals to 48. Correct, na sir? Right? What do you get from here? 12x equals to 48. So x equals to 4. That's your answer. Okay, x equals to 4 is your answer. If you want, you can check over here. 4 square is 16. This will become 32. This will give me 48. 12 into 4 is 48, right? What is this? 8 into 4 will be 32. Here we have 16. Will again become 48 only, right? Please cross check. Your answer for this particular question is x equals to 4. This is clear? Not minus 4, only plus 4. Have a look. Non-zero answer satisfying the matrix equation. Second question, if A equals to sin theta minus cos theta is second element, cos theta sin theta, B is cos theta sin theta, like that, then compute this value. What I have, sin theta multiplied to this part, sin theta to A, matrix A, plus cos theta to matrix B. Let's just do that quickly. Sign with this bacha, sign with the matrix A. What I'll have, first term will become sin square theta, second will be minus sin theta, cos theta, close this. Sin into cos will be again positive only, so sin theta, cos theta for this term. For this I'll have again sin square theta. I hope you agree. Okay, very simple. Cos again we can do, well, what we'll have with the B matrix, so cos square theta, cos theta sin theta. Okay, over here minus cos theta sin theta, over here cos square theta. Add them, what will happen? This will cancel this part as well, this will cancel this part here. If you add them, it will become 0 only, no? So 4 elements are clear. This is 0, this is 0, this is going to cancel, so 0. This is also going to cancel, so 0. What about this? Sin square plus cos square is 1, sir. Identity. Sin square plus cos square is 1. Again same, sin square plus cos square is 1. Answer is what, bacha? Identity matrix of order 2. Okay, simply I. Option A is correct. Please check. Option A is correct. Simple question, very simple. Alright. Matrix multiplication, right? Multiplication of matrices. Whenever you multiply two matrices, how do you do that? One thing very important over here is, let's take a matrix like this. I have here 3 cross 2 matrix. Okay, means let's say A11, A12, okay, and then I have A21, A22, okay, A31 and A32. Okay, how do you multiply this, bacha? How do you multiply this? Please check. With this matrix, I have here B11, B12, B21 and B22. What is this going to be? 2 cross 2 matrix. Okay, so what you do over here, no, you take the first row and multiply with the first column. Okay, and we can do the multiplication over here because this is only one reason. This is equal. What is this called as? Number of rows in the first matrix. If I call this to be matrix A, right? If I call this to be matrix A, number of rows, sorry, number of columns over here, number of columns over here should be equal to number of rows over here. Got it? When you get that right, it means the multiplication is possible. Okay, now what you do after that, you take the first row with the first column. You get what, sir? You get only the first element over here, sir. So you'll get C11. What is next row? First row with second column. First row with the second column. You're gonna get the C12, sir. Okay. Then bacha, if you do second row now with second column, sorry, first column, second row, first column over here, what are you gonna get? C21, and same way C22. So what do? You take row with column multiplication. I'll show you with the help of example, but yes, that's what we do. Let's read it. If A and B are two matrices, then product AB is defined if and only if the numbers of column in A is equal to the number of rows in B. Okay, correct, na? Number of columns in A should be equal to number of rows in B. Okay. Square matrix A is said to be idempotent matrix if I have A square as A. Whenever you get square of a matrix as itself, you call that to be idempotent matrix. Okay, chaliye. Alright, can you multiply this? My question is, can you find here bacha AB? Can you do that? Yes or no? Can you do this? Please check. It is going to be 2 cross 3 matrix. Number of rows is 2, number of columns is 3. Can you multiply this? Okay, here 2 cross 2 is there. Can you multiply, sir? No, sir, we cannot multiply. Not possible. Not possible to multiply here. Okay, if you can't multiply AB, then what can we multiply, sir? We can multiply BA. You check. Can you multiply BA, sir? Can you multiply BA, bacha? If I write BA, is BA possible? Yes. Check this out. For BA, bacha, write B first. What do you have? 2163. Okay. And what do you have for this part? This is 2 cross 2. Okay. For A, you have 312061. Okay. It's going to be 2 cross 3 again. Can you multiply now? Please check. This and this is equal. So number of columns over here is same as number of rows over there. So BA, yes, but AB not possible. That's why I've taken it like that. Okay. Chaliye, let's multiply this quickly and get the result. As I said, first row with first column will give me first element. First row with first column will give me first element. So 2 into 3, sir, is 6. 1 into 0, sir, is 0. I'll repeat myself. 2 into 3, sir, 6. 1 into 0 is 0. Okay. First element is done. Next, bacha. First row, second column. So 2 into 1 is, sir, 2. 1 into 6, sir, is 6. 2 into 1, 1 into 6. Okay. Next, sir, the last one, 2 into 2, sir. Over here, the third column. 2 into 2, sir, is going to be 4. 1 into 1, sir, so plus 1. Correct, now? Now same will go with second column over here. 6 into 3, sir, 18 plus 0. Here 0 is there, no? That's by 0. What else we have? 6 into 1, bacha, will be 6. 3 into 6, sir, again 18. 6 into 2, sir, is 12. 3 into 1, sir, is simply 3. 6 into 2 is 12. 3 into 1 is 3. What do you get the answer to be? Please check. My answer is coming like this. I can write over here 6, 8, 5. Okay, I have 18 over here. I have 24 and 15. This is my final answer for BA, sir. So now I hope you understand the multiplication of the matrices. Yes, let's quickly move on to the questions. Okay, before questions we have to solve some question on understand some topics on matrix multiplication properties. Okay, so what we can say that is true in the case of properties of matrices. So property 1, matrix multiplication is not commutative, means whether you multiply AB and BA not always equal, sir. Think about this only. AB not possible, BA you can do. Then how is AB? Can you say AB equal to BA? Of course not, sir. So not always AB will be equal to BA. Here we can't even multiply AB, right? But even if we can multiply, we cannot say for sure that it is equal. Okay, so not always commutative. We can't say this is true always. Okay, AB is not always equal to BA. Is that clear? All right. Property 2, bacha, matrix multiplication is associative, that is AB. So yes, this is okay. This is all right. Means you multiply AB first, then you multiply with C, or you multiply BC first, then you multiply with A. Same thing. So it's associative but not commutative. Okay, not commutative but associative. Chaliye, third property. I can here, bacha, do this property, no? Distributive law. Means A times of B plus C is same as AB plus AC. So first you add B and C, then multiply with A, or multiply AB together and AC together, then you add, same thing. Okay, so both of them are true. Same thing is there. Please check. Okay, property 4, the product of two matrices can be null matrix. Yes, even though let's say I have matrix A, not a null matrix. Okay, not a null matrix. Same way, matrix B, not a null matrix. When you multiply AB, no, it can be equal to a null matrix. AB can be equal to null matrix. Okay, so even though individually the matrix are not actually a zero matrix, but product can become zero. How come, sir? How come, sir, bacha? Because here, no, if it was, let's say, minus 6 plus 6, it will become 0 only, no? Whatever that. Difference of sum can make it 0. That's why it will depend upon elements actually for that matrix to be null matrix or not. Okay? That's why because of the element, we don't have that control to, say always that case. So, even though A and B is not a null matrix, AB can be a null matrix. Okay? Chali. So, for property number 5, if A is a given, this question has been asked, I think. Okay? So this question has been asked whether they are saying that if AB is 0, what is the correct statement? Okay. Property 5, if A is a given square matrix and I is identity matrix, this is true, bacha. AI or IA is same as A. Property 6, if A is a given square matrix, yes, multiply 0 with A or A with 0, answer will be 0 only, no? So null matrix will come as 0 only, sir. Okay. Chaliye. Now, sir, we have question number 3. Let's quickly solve it. What else is there? A is this, B is this. Then find the value of alpha for which this is true. So we have to find A square, no? Let's do that. Let's find A square. What is A square, bacha? A times A. So alpha 0 1 1. Here also alpha 0 1 1. Okay. Do this first row, first column. Alpha square 0 into 1 will be 0 only, no? That I don't have to write. Okay. Alpha into 0 is 0. And 0 into 1 is again, bacha, 0 only, right? Correct, na? Check this. First row, I'm saying second column, okay? Alpha into 0 is 0. 0 into 1 is again 0, bacha. Chaliye, that's okay. Now compare the second row with both the columns. Multiply that. 1 into alpha is alpha. 1 into 1 is simply 1. Over here, 1 into 0 is 0. 1 into 1 is again 1. What I'm getting now? I'm getting alpha square 0, alpha plus 1 and 1. This is my value of A square. They're saying this is equal to B, right? So right here B. What is B given as? 1 0 5 1. If you compare from here, what you're getting? This is okay. So we have two equations over here. Alpha square equals to 1 and alpha plus 1 equal to 5. From here I get alpha as plus minus 1 and from here I get alpha as 4. But bacha, this is not possible, no? Alpha cannot have this much values, right? It can have only one values, no? So it means no real value. No real value. Means if I take alpha as 4, no? If I take alpha as 4, it will become 5. It will become 16. Can this and this be equal in that case? You might have this argument. You can think, sir, why not, sir? I can take 4, I can take plus 1. But if you take alpha as plus 1, it will become 1. So this will be equal, but this will be 2 over here. If you take alpha as 1, it will become 1 and this will be coming as 2. Not equal to B. Okay, so you can't have a value like that. That's why none of the real values are right answer. Okay, so please check. I'll erase this over here. Okay, so let's move on now. All right, so transpose of a matrix, again very important topic. Questions are useful and they're coming in this. Okay, in the skew symmetric matrix, what we do, we take the transpose, right? So please check what we have over here. The matrix obtained from a given matrix A by interchanging the row and column. So if you take row as column, basically check here, row becomes column 1 2 3 1 2 3. Here's a row 205 becomes column. You call it transpose. Okay, you call this as transpose of the matrix A. What is notation? You write like this, no? A dash, or you write this as sometime AT also. A dash or AT. Okay, think here. The M was row, no? It became column. N was column, right? Became row. So you also see here 2 cross 3 becomes 3 cross 2. Not a problem. Very simple. Chaliye. Properties of transpose of a matrix. What is there for the first property? A, B be any suitable matrix. Then we have A plus B transpose as simply A plus B transpose. Okay. So AT plus BT. Individually we can do that. Whenever your product, no, that is changed. Please check here. Whenever this in product, it will change. If you have AB transpose, no, it will become B transpose A transpose. If you have AB transpose, it will become B transpose first, then A transpose. It's the multiplication of matrices. Okay, please check. Second one, sir, if you have taken transpose of transpose, if I have a transpose, true transpose will become the matrix itself. Correct, na? So row, think about it. The row becomes equal to column, again becomes equal to row. So same thing, no? Right? We are doing the transpose 2 times, right? So row becomes column and column becomes row again. So same thing. That's why it becomes A itself. Please check. Property 3. If you have bacha a constant K introduced over here, okay, then you can write like this. K can be taken outside of the transpose. Okay, over here difference will same act as summation. You can write here transpose minus transpose with the negative sign. Okay, if you have minus sign over here, I can take minus sign common, write as transpose. Basically I'm saying that if I take minus 1A to the transpose, it will become minus common A transpose, same thing. Okay, property 4 already explained you. AB multiplication is there, it will become reverse. This is the most important part. Keep, we keep using this in the questions. Very, very important. Please check. Okay. So ABC transpose becomes C transpose, B transpose, A transpose. We have A, B, C in this order. So C will come first, B will come next, and A will come last. Okay. Chaliye. Now, so question number 4 is there. Let's solve this question. If A is cos x minus sin x cos x, then find A transpose. Find A transpose. So, okay, let's find A transpose first. Okay. It'll become, so you'll have cos. Diagonals will not change, right? So this will become minus sign will come here, and this will go here. So it will become sin x cos x. Please check. All right. Diagonals will remain same, and others element will interchange. Okay. Okay. Multiply this with A. So what I get, bacha? Check this out. Cos x. So first row with first column. So cos x into cos x is cos square x. Okay. And we have minus sin x into minus sin x. So become, bacha, minus sin square x. Correct now? Please check. Cos square x minus sin square. So no, plus sin square actually. Forgive me, plus sin square. Have a look. Cos into cos is positive, and minus sin into minus sin becomes positive. Okay, I've taken minus, that's why I've changed that. Next, what we have? First row, second column. Cos into sin is plus cos sin, cos x, sin x. Next, what I have? Minus sin into cos, minus sin x and cos x. Okay, what else I have? Please check. For the second row now, I have sin x into cos x. So again, it will become sin x cos x. Okay. Next, I have, sir, cos x times of minus sin x. So I becomes cos x sin x again with negative sign. Please check. Sin with this cos, cos with this sin. Second row, first column, right? For the third element. Next, the second row, second column for the last element. Sin x into sin x, sir, is sin square x. Cos x into cos x is nothing but cos square x. What I'm getting? Please check. 1, this is cancelling, so 0. Here also cancelling, 0. This is 1, sir. What is this, bacha? I2. Identity matrix of order 2. Option is there, B. I think all of you must have got this answer, but by just looking at it. You don't have to solve all this, no? You don't have to solve to check this. From your mind, you can see this. Cos into cos, sin into sin, plus, no? So becomes 1 here, sir. That is going to be negative. Okay? Let's move on to question number 5. What we have over here is, they have given P matrix, again 2 cross 2. A is again 2 cross 2. They are asking that this is going to be how much? What are they asking? PT Q 2005. P is how much? Okay. Where Q is given as PAP transpose. PAP transpose. Actually, we know one thing, right? P times of P transpose is how much, bacha? Is 1. PT into P is how much, bacha? 1 only, right? Okay. Not 1 actually. Identity matrix, no? Yeah. I mean identity matrix. Okay. Not 1. So please check. What will I get? I'll get over here as I can change this. P transpose as it is. For Q, I'll write, bacha, this P transpose power 2005 and P. So I will replace this Q value by the Q value they have given. Okay. Now have a look. From here I'll start. So please check. It will become, sir, PT as it is, and I'll write here PAPT times PAPT times PAPT. Okay. Dot. Again they'll write here PAPT. Okay. Times of P. This P is over here. This is, bacha, 2005 times. Okay. 2005 times. Okay. Chali. What else we have? Have a look. So PTP is identity matrix. PTP identity matrix. PTP identity matrix. PTP identity matrix. PTP identity matrix. Correct, no? we'll get like this. So what I'm getting over here, simply I can write here, sir, one entity matrix, and I have A into A into A into A, like that till 2005 times. Okay, so I get here I times of A power 2005, nothing but A power 2005, sir. Great. Okay, we have A value given over here, don't we? Check this out. I have A given as, what is it? 1101. 1101. Let's find A square first. Let's find A square. It will become 1101 with 1101. Check this out. What I'm gonna get? 1 into 1 is 1, sir. No. Yeah, 1 into 1 is 1. Okay, and this 1 into 0 will be 0 only, no? Now this with second column, 1 into 1 is 1, sir. 1 into 1 is bacha, again 1. With 0 I'll get what, sir? This will be 0. With 1 into 0 we'll get again 0. Over here I'll get 0 into 1 is 0 and 1 into 1 is 1. So what is the result? 1, 2, 0, 1. This is my A square. Let's find A cube now. Let's find A cube. A cube will be A square into A. How much is that? 1201 times of 1101. है ना? A square is 1201 and A is 1101. Let's multiply this. So I'm getting A cube as, have a look, 1 into 1 is 1, 2 into 0 is 0. First row, first column. Now first row, second column, 1 into 1 is 1, 2 into 1 is 2. Second row, first column, 0 into 1, 0, 1 into 0, again 0. 0 into 1, 0, 1 into 1 is 1. What is the answer? I'm getting this as 1301. So you can check here. Please check what I'm getting. When I had A square, no, this became 2. When I had A, right, it became 1 only. When I am having cube, it will become 3. So if I write this as, keep going like this, I'll write here A2005. I'll get this as 1, 0, 1 and 2005 here. Correct, no? Check the trend. When the power is 1, this is 1. When the power is 2, this is 2. When the power is 3, this is 3. When the power is 2005, this will become 2005. Okay. Correct answer will be option A only, right? Option A is correct. Please check. Option A is correct. So let's move on now. So this is done. Okay. Symmetric and skew symmetric matrices. Symmetric and skew symmetric matrices. But whenever along the diagonal, first of all, along the diagonal, this is applied only for square matrix. This is very understanding thing. It cannot be applied for rectangular matrix. When the order is basically means number of row and number of column is same, then only we can apply this property. Okay, so M and N should be equal to each other. Okay, all right. When that is there, check here, we have N and N. Correct, no? When that is there means I can apply this property. What is that? This will be symmetric, bacha. About this diagonal, no, you will find the symmetric relation. Check here. Check here. So this element will be equal to this element. So I'm saying that A13 will become equal to, so A12 will become equal to A21. A13 will be equal to A31. Okay, and you'll have A23 will be equal to A32. So basically, Aij becomes equals to Aji. Aij becomes equals to Aji. That's called as symmetric matrix. What about skew symmetric, sir? You will have a negative sign. So you'll have Aij becomes equals to negative of Aji. What I mean by this, please check. You'll have A12 equal to minus of A21. So A12 is B. So what is A21? Negative of B. Like that. G minus G. This will be 0, okay? Diagonal will be 0, bacha. You'll have B minus B, G minus G, and F minus F. So Aij will be equal to negative of Aji. Please check. Okay. So whenever you have A dash as A symmetric, whenever you have A dash as minus A, it's going to be skew symmetric, sir. Please check. A dash equals to A is symmetric. A dash equals to minus A is skew symmetric. Alright, this is clear. And again, diagonal will be 0. Correct, now? Think about it. A11 equals to minus of A11, na? Bring over here, I'll get, what do you get? right? Correct, na? A11 equals to negative of minus A11, so becomes equal to 2A1 equals to 0 means A11 is 0 by 2, which is nothing but 0 only. Okay, let's move on. Note every element in the principal diagonal of the skew matrix is 0. Okay, now some knowledge hub. What is there in the knowledge hub today? We have here is, let A be a square matrix, then A plus A dash is a symmetric matrix, bacha. For any square matrix A, if you add A and its transpose, it will become a symmetric matrix. Okay, but if you take subtraction of that, if you take a difference of A and transpose of A, you'll get skew symmetric matrix. What are you gonna get? Skew symmetric matrix. Okay, and A dash and A dash is symmetric matrices. Okay, please check. This is the very important things to know. You're gonna use this in questions. Okay, even in boards, very relevant. The first two. They asked you actually one question on this for 5 mark, I think. Okay, any square matrix can be uniquely expressed as the sum of, yes, any matrix, bacha, any matrix A can be written like this: half of A plus A dash, half of A minus A dash. This is nothing but your symmetric part, and this is a skew symmetric part. Correct, na? You'll have a symmetric and a skew symmetric part. This is a symmetric part, this is a skew symmetric part. Clear? Okay, chaliye. Now inverse of a matrix. Okay, for any matrix A, you'll always have one matrix B which will be written like this. Please check here. AB into BA will give me always identity matrix. Means for any matrix A, I'll have a matrix B which will, in product, will give me, bacha, identity matrix I. If I take BA also, that also is correct. So BA will also be equal to I only. Of the same order, of course. Of the same order. So if it is AN, no, it will become IN. Same order, bacha. Please check the mentioned over here of order n, right? Of the order n. Please check of the order n. Okay. And how we write this as? We write simply B as inverse of A. How we write, bacha? B as inverse of A. A inverse. Okay. How do you find it? We learn in determinant. But just understand this. Always there will be a unique matrix. You can't have two matrices. You can't have, let's say, for a matrix A, you can't have two inverse B and C. If it's there, means B will be equal to C, sir, actually. Okay. Yes. Okay. Chaliye. Yes. What else we have? Inverse of a square matrix is, if it exists, it will be always unique. Okay. This property is again very useful. If you are taking product to the inverse, B will come front and A will come, next. So B inverse into A inverse you do. Okay. Again has to be of the same order. Please check. Let's move on now. Question number 6. If A equal to I minus I, B is this, then A equals to how much? Okay. A is I minus I, minus I and I. Can I take minus sign common? Now can I take I only common, not minus sign? Can I take I common? It'll give me something in relation with B actually. 1 second. If I take, sir, here I common, what will have? I'll have here 1 minus 1 minus 1 1. Same as this. It means I'm getting, bacha, A equals to IB. A equals to IB. What is I, bacha? Iota, okay, the complex form. A equals to IB I'm getting over here. Have a look. So how you write, bacha, A8? You write A8 as A power 4 the square. A power 4 square, please check. Okay, that's 8. So basically, I can write here A square into A square, this whole square. Can you find A square once? Please check. Can you find A square, sir, over here? Sorry, for A square, what I'll have? I'll have B, no? I'll have actually B over here left. So I can write this as IB the square into IB the square whole square, na? Correct, right? What is A square, sir? A is nothing but IB, right? So I'm writing A as IB the square, A as IB the square, and then we have whole square. So I need the value of B square once. What is that going to be? 1 minus 1 minus 1 1 into 1 minus 1 minus 1 1. Please check. Someone get this as first row first column. Apply this. 1 plus 1 minus 1 into minus 1 is plus 1, no? Second bacha will become minus 1 minus 1. Over here again I'll have minus 1 into this minus 1 and plus 1 again. Sorry, minus 1 again. So minus 1 minus 1. Minus 1 into 1 is minus 1. 1 into minus 1 is again minus 1. second row, second column, minus 1 into 1, sorry, minus 1 into minus 1, plus 1, and 1 into 1 is 1 again. So I'm getting here b square equals to 2b. Okay, now check this out. This will become I square, okay, I square I have, and then I have here b square, and I'll have again I square and b square. I have whole square of course. I square is what, bacha? Minus 1. What is b square, sir? 2b. Okay, this again is minus 1. This is again 2b, the whole square. All right. Okay, 1 second. Give some space over here. I'll need this space. Okay, looks a little messy. It's all right. What I'm getting now? I'm getting here a power 8 as, have a look. What I have, minus 1 and minus 1 will be becoming plus. That is all right. What I'm getting now, bacha? 4b ka whole square, sorry, 4b square the whole square. Okay, which will give me 4 into what I have over here is, please check, 2b, right? Correct, na? B square is again, bacha, 2b only. No, wherever you get b square, write as 2b. I had b square, 2b, b square, 2b. Here also I'm getting b square, so 2b. What I'm getting, 8 square, na? So 8b the whole square. What is that going to be? 64b square. Correct, na? 8 square is 64, b square is simply b square. Again write this in terms of, what do you call, 2b will become 64 into 2b. What is the answer going to be? 128b, bacha. This will become 128b, sir. 64 into 2 is 128. Please check. So my a power 8 is coming as 128b, sir. Option B is correct. Option B is correct. Here's your final answer. Please check. This is your final answer. 128b. Okay, looks messy, but it's actually very simple. Looks a little messy, but actually very simple. Have a look. Right? I hope this is visible to you. Okay, let's move on to question number 7. Okay, this is, I think, the last question of the day. I've taken some multiplication over here to ease our work, to make this thing, take less time. What do we have? If a is 1 0 0 0 1 1 0 minus 2 4, then this also is true. 6a inverse equals to a square plus alpha a plus beta I. Then find beta minus 5 alpha. Okay, let's find this. Let us find this value. So what we need, sir, we have here, they have given this 6a minus a square plus alpha a plus beta I. To bacha, think about this, to solve this equation, because we need to value b and beta and alpha, right? I have to solve this equation, correct, right? So let's do one thing, multiply a on all of this, all the terms, multiply with a. When you do that, you'll get get rid of a inverse actually. So right here, a6 times of a inverse equals to a times of a square plus alpha times of a square plus beta ai. Okay, think about it. It'll become simply I, sir. So I'll have 6i equals to a cube plus alpha a square plus beta a. Ai is simply a, sir. Okay, so what I have now, think like this. I have, so 6i. What is alpha cube? Sorry, what is a cube? I have a cube already in here. A cube is a square. First you find a square, okay? So when you find a square, you get like this 1 0 1 0 0 0 1 1 0 minus 2 4. Same thing, multiply this. 1 into 1 is 1. 0 into anything will be 0 only. So only 1 is the first term. Same thing, you take bacha first row with the second column to get the second element. 1 into 0 bacha will be 0. 0 with anything will be 0 only. That's why 0. Again, you multiply 0 with anything, you get 0 only. Okay, please check. So you'll have this is your result for a square. Same way you get for a cube as a square into a. So multiply this with this, you get the answer as this as a cube. Okay, please try. If you want, please try. Okay, now what are you gonna do? Put the values over here. What is a cube, sir? 1 0 0 1 0 0 0 minus 11 and 19 I have. Okay, what else I have? 0 minus 38 and 46 I have. Okay, 0 minus 38 and 46 I have for a cube. What I have for alpha a square? In the a square, wherever I have terms, multiply that with alpha. A square, wherever I have, multiply with alpha. So wherever I have 1 and 5 other numbers, I multiply with alpha. So I have first term as alpha. This is 0 0 0 0. Okay, minus alpha 5 alpha. minus alpha 5 alpha. Again we have minus 10 alpha and 14 alpha. Minus 10 alpha and 14 alpha. Please check. Please check. Minus 10 alpha and 14 alpha. This is again done. A alpha times of A square. Now I have B beta times of A. Plus wherever I have the number multiply with beta, so beta 0 0, and again I have 0 beta beta. Okay, I have 0 minus 2 beta. Okay, and I have 4 beta. Alright, this is done. Now can I write this over here? 6i means 6006. Okay, can we add all of this together? Of course I can, sir. 1 alpha beta, 1 plus alpha plus beta. This is 0, I think. Everywhere is 0 only. What I have? 0 0 0. So this is last two terms are 0 and 0. Okay. Okay, 1 second. What next I have? Think like this: 0 plus 0 plus 0. Then I have bacha minus alpha minus 11 and beta. This is 0. This is also 0. I have minus alpha minus 11 and beta as a second term. Okay, I can rewrite this. 1 second. Just a second. This is the last step, bacha. Little patient. Minus alpha minus 11 plus beta. That is it. Have a look. Minus alpha minus 11 and plus beta. Last is 19 5 alpha and beta. 19 5 alpha and beta. Okay. Last element. Last two. Please check. I have some minus 38 minus 10 alpha and minus 2 beta. Minus 38 minus 10 alpha and minus 2 beta. Okay. And what else I have? 46 14 alpha and 4 beta. 46 14 alpha and 4 beta. Anyway, that's not relevant actually. I'll tell you why. I want to write this, that's why I've written over here. It doesn't matter actually, because just by looking at these two, I get the answer. Just by looking at these two, I get the answer. 1 second. I made a mistake over here. I've written 2 cross 2. It has to be 3 cross 3 actually. It has to be 3 cross 3 actually. So it has to be 6 6 6 0 0 0 0 0. Okay. Correct now? It has to be 3 cross 3. Okay. So please compare here. I get 1 plus alpha plus beta equals to 6, and second one, what I get, bacha? Minus 11 minus alpha plus beta equals to 6 again. I'm comparing these two. Please check. I'm comparing here this one with this one and this one with this one here. Okay. So when you add them, you get here this and this is cancelled. I get here minus 10 plus 2 beta equals to 12. So 2 beta equals to 12 plus 10. Hence beta equals to 11. Right? Beta equals to 11. Use any of them. 1 plus alpha plus 11 equals to 6. So alpha is 6 minus 12. Alpha is what is it? Simply minus 6. Okay. What are they asking? Beta minus 5 alpha. They are asking, sir, beta minus 5 alpha over here. Please check. Alright. So what I get now? 11 minus 5 times of minus 6. So 11 plus 30. 41. What is it? 41. Option A is correct, sir. Option A is correct. So have a look once again. Here as well. That's it. This completes your session on your matrices for Masterstroke one shot. I have tried to revise everything which is there in your syllabus in one video. Let me know if I have missed something. If I have, I'll again come up with a session to help you in that. Okay. Again, I've taken only 7 questions. So if you want more questions, what you can do is follow me in the live session when I'm going to solve more questions in this particular chapter. Otherwise, you can go ahead and check the original series 60 of 16 KCET Mathematics. You'll have 3-4 sessions there. You can solve PYQs also with me. Okay. Please go ahead and do that. Achha, one thing I can request you to do, that is whatever one shot you're watching, watch one shot, solve live with me, but do the PYQs also that I've done already. I've already done the PYQs, right? So go ahead in that session, please solve all the PYQs. Okay. So with this, I'm going to end the session today. I'll see you again very soon. Till then, take care. Bye-bye.